core part of the collections framework is the set interface. Whenever your requirement is not storing duplicate values, you'll use the set interface and its subclasses because a set doesn't allow duplicate elements. The three general purpose implementations of the set interface are HastSet, TreeSet, and linked HastSet. In this video, we'll have a look at two implementing subclasses of the set interface, that is the HastSet and the TreeSet. HastSet is an unordered, unsorted collection, and TreeSet gives you a sorted collection in natural ordering. And based on your requirements, you will use particular set implementations, whether that is a HastSet or a TreeSet or a linked HastSet. But wait a moment. You might be wondering, what does this image has to do with the set? Well, nothing. This image came by default with the slide and I didn't feel like changing it. Well, let's think about learning sets similar to this mouth-watering dish right here. Let's jump right into our IDE and get our hands dirty by writing some actual code. So I've created a class here called working with sets because that's what we are going to do now. And we are in the main method and I'm just going to start doing it with the first implementation of the set interface, that is a HashSet. So let's just do it. Whether you're doing a polymorphic assignment like this, I'll just implement or import the set interface from java.util again. And we'll just say, let's say for now, we're just having a string only set. So I'll just call it set of names. And I can do a polymorphic assignment with an HashSet. And why polymorphic? Because again, on the left side, we have the reference type of set, and on the right, we have the implementing object type of HashSet. So you can go with this kind of an arrangement or just put it to the same type on the left and the right, whatever works for you. So this is a HashSet. I've called it a set of names, and it can only store strings because we have defined the generic argument like that. So next, let's just add some objects into the set of names, and you know we can only add strings now, right? So I'll just put in some strings objects here into the set here. Let's just say the first object, that is Gargi, as a string. We'll say Bhupesh, we'll say Umar, and we'll say John. Right. 4 string objects inserted into this HashSet, which I've called set of names, right? But until now, because first things first about a set, whether it's a HashSet or a TreeSet or a linked HashSet, you cannot store duplicates. And that is the first consideration for storing values in a set, right? That is, you don't want duplicate items to be stored. Now, if you try to store one duplicate value here, let's say set of names dot add, and I'll just say again Gargi. This here would not be stored, but you'll not get an error as well because the add method that you're using here has a Boolean type as a return type. That is what you're seeing here. And that means if the element is added into the set, it will return a value true. But if the element already exists, it would not be added and you will get a false. I'll say no error here, but wouldn't be added. And you know why? Because Gargi is already existing in our set, right? But we should just get a false here if we want to print it or put it in a condition. But I've not done that because I don't want to do that here. That's not my requirement, but you'll only find Gargi here. And the next point about a HashSet is that is it stores, that is there is no particular ordering in which the values in a HashSet are stored. Right? It's an unordered, unsorted collection, the proof of which you'll get when we print it out. And I'll just print it out with a for loop and we'll say a set of names again. And let's just use, because it's just one line of code, we'll just use the Java 8 for each, right? Which makes up for quite succinct, precise, and better readable code. I'll just say system.out method reference print ln. And whatever there is in our set would be printed, right? And I'll just put in a println message at the top as well. I'll say values stored in the set. let's say what they are. And you'll see, you'll get elements in no particular order, because remember again, it's an unsorted, unordered collection, and also the duplicate value Gargi would not be there. That is, those are the properties of a set and a hash set in particular. Let's save and run this. And say proceed, because there is some error in other classes and we're not concerned with those right now. See, values stored in the set are, you'll get Bhupesh, John, Gargi, and Umar. Now, things to be considered here are, that is the first thing is, that is unsorted, unordered, because see, although we added Gargi first, we pushed Bhupesh next, but we got Bhupesh first, then John, then Gargi, then Umar, in no particular order at all. Again, proves that HashSet is an unordered, unsorted collection. The next thing you are observing here is the second object, the duplicate value for Gargi we added, was not added into this set. And these are the properties of a hash set, right? Unordered, unsorted, and duplicates are not allowed. Let's quickly have a look at the other type of set, the other implementation, the other implementing class of a set, and that is a tree set, right? And which again would not allow you to store duplicate values, but other than that, now TreeSet is an ordered and a sorted collection, and it's sorted in natural ordering. That's the difference between a hash set and a tree set. So what I'll just do here, I'll just replace the hash set to a tree set. Let's do the polymorphic assignment here. Yeah. Let's set it to a tree set, and we're not using a hash set. I'll just comment that for now. Again, the same objects, Gargi, Bhupesh, Umar, and John, and let's just add one more. I'll say set of names dot add, and let's say we're adding Akanksha, right? So then again we are adding a duplicate object. Again, it would not be added, because remember, even if we are using a tree set, right, but still it is a set, it's an implementation class of a set. That is why it would not allow us to still store duplicates. Again, no error, but would not be added. But this time when you see the values stored in the set, they would be printed in the sorted order of natural ordering. First, you should get Akanksha, because A comes first in alphabetical sorted order, right? So let's have a look at that. Let's see what the error is here. I think we can ignore this for now. Save this and let's run this. Again, let's say proceed. And let's have a look at our console. It says there's an unresolved compilation error. Set of names. What's wrong here? Yeah, like this. Generic arguments, right? So let's save and run this. Again, proceed. Here you go. Values stored in the set are, now things to be observed here. The first thing is, see, A, B, G, J, and U. That is in alphabetical chronological order. Akanksha, Bhupesh, Gargi, John, and Umar. Although we pushed Gargi first, right? That is, TreeSet gives you a sorted and ordered collection. And the second thing, still, the duplicates are not allowed. Gargi has not been added to our set because it's a hash set, it's a tree set, doesn't matter, but it is a set which does not allow duplicates to be stored, right? So that is what a set is, and why and where you would use a hash set and a tree set. I'll see you in the next video.